Hi, everyone. Just to let you know, we'll start the presentation in about 1 minute. Thank you so much for joining us. Hello again, everyone. Just to let you know, we'll start the presentation in about 30 seconds. Thank you once again for joining us. Hello, everyone, and welcome to today's Safety and Health Magazine webcast, Electrical Safety, OSHA and NFPA 70E Requirements, sponsored by J.J. Keller. This is Alan Ferguson. I'm Associate Editor at Safety and Health and co-host the On the Safe Side podcast, and I'll be moderating today's event. Thank you so much for joining us, and before we get started, there are a few housekeeping items. As a disclaimer, the views of today's speakers and organization are their own and do not necessarily affect those of the National Safety Council or Safety Health Magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or the magazine endorses those items. After today's presentation, we'll conduct a question and answer session with our speaker. If you have a question, click the Q&A button at the bottom of your screen, type your question, and press the send button. We welcome your questions at any time during today's event. You don't have to wait for the Q&A to begin. We might not get to every question, but the good news is unanswered question we forwarded to today's sponsor. Also, after this presentation, you'll be asked to complete a brief evaluation survey, and I'll tell you more about that a little bit later. Just to let you know, this webcast will be archived so you can access it after today's live event to view this webcast and all of our past webcasts. Please visit safetyandhealthmagazine.com/events, or you may also receive a link in our post-event email. With that, let's introduce our presenters. With us today is Phil Hadia and Ray Chishti. Phil is a safety consultant with 25 years of experience working in commercial and industrial locations. Since 2016, he's helped people across the country improve their approach to electrical safety and become aligned with NFPA 70E. Phil is a member of the Project Management Institute, National Fire Protection Association, and the American Society of Safety Professionals, among a variety of other industry groups. Ray is a senior EHS editor at J.J. Keller, joined the organization in 2017. He has 15 years of EHS experience in a variety of industries, including EPC projects, construction, railway, fossil fuel power plants, electrical transmission, retail, and gas distribution and transmission. Phil, whenever you're ready, go ahead and take it away.
All right, very good. Thank you, Alan. Today's webcast is sponsored by J.J. Keller Consulting Services. At J.J. Keller, we're experts in OSHA compliance, safety, and related best practices. With over 65 years in business and 70+ regulatory specialists on our team, we're well equipped to help protect your company from an OSHA inspection. Working with companies from coast to coast, our EHS consultants offer significant value to businesses by identifying their risk areas, then delivering continuing oversight, training, and resources to help manage them more effectively. So on behalf of today's sponsor, J.J. Keller Consulting Services, thanks for joining us today. And today we're going to be talking about electrical safety. And myself, like Alan had mentioned, I work only in electrical safety. So I do a lot of field audits, a lot of safety training. I'm a registered instructor with the Department of Labor in Minnesota, Wisconsin, Iowa, and Alaska. And so I've written and submitted and gotten approved courses that are CEU level courses, specifically for electricians in those states. Master and journeyman electrician, just my experience working in the field, are a lot of times resistant to taking training on electrical safety issues or items. And it has a lot to do with them already being in training classes a lot, just keeping their licenses up to date. So I have a heart for electricians, and I thought if I created CEU level classes, it would maybe compel them to get into safety training more than maybe they might be willing to in the past. And some of you may ask yourself, well, why is it that electrician doesn't want to go to training? Well, it's because these folks have been working with their hands for decades and decades and decades in a lot of instances. Many of them have gray hair like myself, been around for a long time, and maybe aren't really always feeling the need that safety training is important to them. But OSHA has adopted NFPA 70E as that standard for electrical safety and training and all these things that relate to electrical safety back in 2004. So it's been a long time. They adopted it by letter of reference. So it does not apply to ships, does not apply to railroads, automobiles. So in my area of work, I often get questions that might relate to those type of things. And I'm a SME on NFPA 70E type of things. I'm a certified electrical safety compliance professional, which means I used a very specific pathway within the NFPA offering of certifications. And specifically for me, it's electrical safety. So even though I've done a lot of pipe and wire work, I've done a lot of troubleshooting, I've installed a lot of equipment, I've troubleshot a lot of things. Today, I don't necessarily work with my hands, but I spend a lot of time in front of a classroom and also doing field survey work, identifying risks that are associated with power system installation. And some of them might actually be a risk associated with misinstallation too, as well, as far as maybe there's might be areas where there's over-duty equipment or that type of thing. So myself, I'm a field guy, so I really appreciate everybody on our call today. And what our agenda looks like for today is we want to talk about some of the hazards. I've got a few examples of things that you can do to make things safer. In the world of safety, we are mandated by NFPA 70E to push the safety needle on electrical forward. So it wouldn't be proper for me to just put on my electrical safety PPE and go about working in the same hazard areas as I always have, and without taking some effort to make these things safer. So it's very important that we take that approach. And myself, it's really hard to sometimes recognize that people are in electrical safety PPE. For instance, my shirt that I'm wearing is indeed, it's an arc flash rated flannel shirt. And so there's a lot of change that is happening within our industry around PPE, around tools, around elements that revolve in this electrical safety space to make them easier to use, more comfortable to use, and to make them in the end more adoptable by people working out in the field, so that way they can use these things instead of maybe, in my case, maybe going and finding a set of coveralls to jump into if I'm going to go do electrical work. So pretty interesting. The risk assessment, hazard assessment process, we'll spend some time on that. We'll spend time talking about qualified people versus unqualified people. I'll hit on training requirements. Ray is going to talk about site audits and task audits, those type of things. Ray, we'll spend some time in lockout tagout as well, and try and give you a pretty good high level view with some detail with relation to a lot of these electrical safety items. So that's really what our plan is for our hour together. Electrical hazards, when you take a look at what actually can happen when something happens with electrical, probably the most common is electrocution. So those shock injuries manifest themselves on people, and a lot of times people won't respond to them in a way of even actively seeking any kind of medical support or medical help from them. And I've met a number of people that have had long-lasting injuries from electrical shock incidents where they did not seek medical help. Would seeking medical help when that incident happened have changed anything in their future life? I'm not 100% sure, but we want to take action, immediate action, if somebody has been shocked or electrocuted or possibly been electrocuted in that area. And we'll talk more about the NFPA 70E requirements of that. NFPA 70E refers to it as contact release training, and we'll talk about that. Burns, the big picture area around arc flash is the burn injury that can result. And I know people that have been burnt in all kinds of ways, where their hands are burnt, maybe their face got burnt. I have a friend of mine who showed me a picture of him after an incident he was in. The skin was kind of dripping off his face. The burn injury on his arm actually burnt around where his watch is. So he had blister burns except where his watch was on his hand and on his arm. So some pretty horrific things there. The other parts of this electrical hazard things that can hurt you, the vapor, obviously there's a vapor, there's smoke and all those type of things that are coming out of that fireball. All the shrapnel that can be sent at you. And I don't know, obviously I don't know if anybody on our call has ever had sunburnt eyes or ever had intense light damage to their eyes. But from personal experience myself, I did not have it happen via arc flash, but years ago I worked in a roofing trade and I had sunburnt my eyes working on a roof in South Florida with aluminum foil coated insulation. And I remember that situation way back in those years, 25, 30 years ago, and I wouldn't wish that on anybody. And so when we see these situations where there's big electrical explosions, the UV light and everything that's associated with, it can cause damage to eyes in, of course, in a horrific way. But even the light damage to our eyeballs, we only have 2 of them to live with, and it can be a real challenge for people to recover from them. Number 1 cause of arc flash is a careless device cover removal, or pulling the cover off of an electrical panel, or pulling the cover off of a control panel or something like that. And a lot of times what has happened, just me visiting with people that I've worked with, they've seen, I get stories, right? Because I do a lot of training, and I get people talking about these situations that they've been in. And when they're pulling the cover off, items could be loose underneath there. I've had people trying to struggle with the cover of a breaker panel, for instance, and then when they moved, the corner of the breaker panel got hit into the electrical gear and caused a problem. You know, all these they seem like they're very unlikely scenarios, but when they do happen, the result of them, that instance or that situation, can be just absolutely horrific. And so we want to go through some great measure to, one, try and change our behavior around electrical safety, so maybe they don't happen in the first place. But if they do happen, have a plan in place. If somebody gets electrocuted or shocked, what are we going to do? Or if there's an arc flash that happened, how did we protect ourselves from the burn or the thermal injury? Or if we do have incidental contact with some sort of energized piece of equipment, to make sure that we're not getting electrocuted from that. And it ends up being a fairly, when you think of the whole big safety picture, it ends up being, it's seeming like a fairly small sliver of the whole, all these hazards that people have to work within. But that little small area of safety, when it comes to electrical, what I've found over the years of involvement in this is people a lot of times get uncomfortable with having conversations about it, simply because they don't understand how electricity works in given situations. And that becomes a little bit of an issue. So that's an area I work. That's all I do. I do arc flash risk assessments. I do electrical safety training, and I help people with electrical safety program development and implementation. And that's it. So not 90%, probably 70% of my time is traveling somewhere. The other chunk of my time is working out of my office. So it ends up being a pretty rewarding thing to do. I get to work with people like myself that have a fair amount of gray hair, and maybe teach them some new techniques with electrical safety that they may not have otherwise talked about. This idea of arc flash, many of you have seen videos to take a look at what this arc flash situation looks like. Very hot ball of plasma. It can get instigated by a variety of ways. There's testing that can be done to determine how big these things can be. So we look back into history. In 2002 is when the science became a bit better understood. And that's when IEEE wrote some standards around how do we determine this for industry? How do we estimate the intensity of this fireball situation? And that math package, if you will, if you looked at it, if you bought the IEEE a publication for it, it's pretty interesting. They've got it laid out well enough where somebody could actually model it in Excel if you're super handy with it. We've done that. You got to be handy with Excel in order to do it, right? It's not an easy thing to do, but it's doable. And then fast forward for 16 years, that math system was the same. And a lot of work was done by IEEE. A lot of money was invested into this whole problem to help understand it better. And an update was made to that in 2018. So a lot of times when I go see somebody, if the labels they have on their equipment are prior to 2018, it was done with the 2002 understanding of how these things work. So now today, when we do this math and do these type of things, the standard we go back to and methodology that we would adopt for these situations of understanding what happens with breakers, what happens with arc flash, what happens with all these things, comes from a publication in 2018. And I would expect, just like everything with the speed of knowledge development in a growing trade field, I would imagine that we're going to see something relatively soon again, that it's not going to take another 16 years for an update to things, because there is a lot of money being spent in this area to create better tools, to create better methods, to create better equipment to help mitigate these arc flash hazards and reduce them. But even with all the talk about arc flash hazards, I think it's pretty understood that more people die by electrocution than necessarily die by being burned to death. In a general sense, also, when people are horrifically burnt by an arc flash, they're generally being burnt because they're not wearing PPE at all. So getting people into PPE to protect them from shock hazards and arc flash hazards, very, very important to make moving forward on that. But still, you'd be surprised. I get a lot of resistance on it when I visit with people about it. So we're going to move over to Ray and have Ray talk about OSHA Subpart S.
Right, Phil, good information. Thank you and welcome again, everybody. So just to provide some context and some structure around the standards, right? The two big questions we get asked are usually centered around Subpart S for OSHA, and then also how NFPA 70E relates to OSHA, even whether or not OSHA has adopted NFPA 70E. So on the OSHA side of the fence, we look at Subpart S, and that's going to cover your standards for example, design safety standards, which are covered through 1910-302 through 308. And then you have the electrical safety related work practices standards, and those are going to be covered through 1910-331 through 335. So that puts the OSHA electrical safety standards on the radar for you. And then, where does NFPA 70E come from? So OSHA's electrical standards are based on NFPA 70E. However, remember that OSHA has not adopted, by reference, NFPA 70E. Obviously, OSHA recognizes the importance of NFPA 70E and will actually refer to it. If they're writing a general duty clause citation, they'll actually say something to the effect, one feasible way to correct a hazard is to comply with NFPA 70E, but they have not adopted by reference NFPA 70E. And the incorporation by reference process, that's simply during the rulemaking process. If OSHA is going to adopt a consensus standard and give it essentially the same effect as their own standard under the law, they'll go ahead and mention it during their rulemaking process in the standard. You'll see it in the list 1910.6. And so again, NFPA 70E does not appear there. But again, just remembering that OSHA views NFPA 70E as that primary consensus standard when we're talking about electrical hazards, in particular with electrical utilization systems. So that gives you some context around OSHA standards, and then also where NFPA 70E comes into play. And I think that that's, we get a lot of questions centered around that, how that affects your workplace. Let's see here. Phil, you might have to advance the slide there for me.
Yeah,
so on this, thank you. On this next one here, we're going to get into, we like to talk about the hazard risk assessment process. And I think it's important to talk about this early on. In particular, when it comes to PPE, employers have a duty to make sure that they're doing a PPE certification. They're looking at the hazards that your workers are going to be encountering, and that they're selecting the appropriate types of PPE. And they usually gravitate towards 1910-132. But we like to point out that 1910-132 does not apply to respiratory protection and electrical protective equipment. The electrical standards that I covered earlier on the earlier slide under Subpart S actually have their own requirements for electrical PPE. But realizing that in conjunction with typical electrical PPE that Phil and I are going to be talking about, you're still required to do an assessment for any other types of PPE that you're going to need. So you wanted to make sure that you identify who are your affected employees. You're selecting the appropriate types of PPE. You want to make sure that they know how to use it. And another big one, and I've seen a lot of issues with this over the years, is fit. It's not a one-size solution. Nowadays, I've seen many injuries and safety events and incidents occur because workers are wearing either too large of PPE or it's undersized. And so it's essential that we're making sure that the PPE that we're selecting for workers are properly fitting them as well. All right. Let's go to the next slide here. On this next one, just to put into context some things that you should be thinking about when you're making that initial survey. Any impact hazards that your workers are going to be facing, penetration, maybe compression hazards, could be chemical hazards, right? That they could be encountering. Any heat. Heat has been on the radar, obviously, with the summer months, setting national record-setting temperatures across the nation. So heat, even indoor heat stress issues. So it's not just an outdoor hazard. Harmful dust, light radiation, and then obviously, as Phil had talked to earlier, electrical shock and arc flash are going to be important as well. We'd like to hear from you on this next slide. We're actually going to do have you talk to us. And actually, I'm getting ahead of myself. In a moment, we're going to be talking to you and having you fill in the chat box. But just some other things that you're going to be encountering. The high temperatures, as I mentioned, those chemical exposures, falling objects is another one. I've seen nowadays a lot of companies have transitioned between the type 1 hard hats to the type 2 hard hats that offer the lateral or the side impact protection. And so you want to be mindful of that. So when you're doing your survey, make sure that you involve your competent and qualified person, right? A lot of times I would find that, the safety person is tasked with the responsibility, and maybe they're your SME, but maybe not. Maybe they're not the true experts. And so make sure that when you're doing your assessments that you have that qualified electrician or your competent persons doing the survey with you. So on this next slide is where we're going to get to the chat. We want to hear from you. Go ahead and put your responses inside of the chat box. Just curious to see, who performs your hazard assessments. Are you doing them in-house? Are you having an expert come in, maybe a consultant, third-party consultant? Maybe you're not sure. Maybe you have a little bit of both. What are you guys thinking? Looks like we got a mixed bag. A lot of folks are saying in-house. We got a lot of folks going third-party outside of the company. A little bit of both. So we got a mixed bag, right? And I can't stress enough that whether you're using the in-houses or external resources, that you're making sure that those persons are going to be competent and or qualified. So that way you have the best assessment forward. So thanks for participating in that. And then also throughout today's webcast, you can send Phil and I your questions. So use the Q&A box for that. All right. And I'm going to pass the baton back to you, Phil.
All right. Very good. Thanks, Ray. So in the world of electrical, when we do hazard assessments, a couple of things we want to think about. We have to think about probability, or what's the likelihood of these things happening. We have to think about severity. And when we think about that severity term, how do we determine how severe for instance, an arc flash incident can be, or how severe could an electrical shock incident be? And so if we think about that area, we actually, in the world of electrical, we have two hazard tracks. One is the electrocution hazard track, and one is the thermal or arc flash hazard track. And with electrocution, a lot of those conversations are done around system voltage. And so NFPA 70E outlines some barrier or boundary areas, restricted approach boundary, limited approach boundary, that pertain directly to voltage. But a lot of times when I do training, I'll ask people if they can tell me what the voltage is of a particular thing is, and I get some hesitation. Then I'll kind of, all right, let's backtrack a little bit, and I'll have people, hey, raise your hand if you use a voltmeter as part of your job. And I'll get a lot of people raise their hand Then I'll go back to the earlier question and say, okay, what's the phase to ground voltage on a 480 system? And I get a few blank stares. So it's a lot of times there's a lot of skills that could be better taught maybe for some of these workers that are using some of this equipment so they can better understand what these voltages are supposed to be. Because the voltage is really the driver for how do we select our voltage rated gloves and those boundaries, so that way we're wearing them when we're supposed to. And in some instances, we don't need to wear them. So as long as we can avoid contact. So there's some of that ends up being an interesting conversation with people. And so sometimes when I'm asking questions as well, so if you think of a set of voltage rated gloves, Ray mentioned having the proper fit for your situation. And a lot of times voltage rated gloves, people will try and use a one size fits all approach. So I'll go somewhere and say, hey, what size voltage rated gloves do you guys wear? And somebody will say, well, I wear size large. And in the world of voltage rated gloves, there's no such thing as a large. It's a number from 7 up to 13 or something like that. So it always one of those things that's not necessarily a gotcha question, but it's designed to kind of like, where are we at? What are people's understandings of how these things work? When we get back to doing arc flash risk assessments, there's two ways. One is called the incident energy method, and the other is called the PPE categories method. The PPE categories method has been around for a very long time. It was developed maybe as a simplified approach, or that's what the original intent was, from my understanding from people I've talked to that may have been part of that conversation 20 years ago. It was designed to put a little bit, ease the burden of determining what PPE is required, but still, even after all these years, what I found is most people, if they tell me they use the categories method, I find that they're telling me that to try and get themselves out of a jam because it's a very uncomfortable conversation with them. They don't want to really enter into that fray. The other method is called the incident energy method, and that's the one where you see on this label, there's 1.2 calories per square centimeter of arc flash hazard at 18-inch working distance. And that's the one that becomes, it's a more precise conversation, and it gives a better view of the situation. And in some cases, it actually validates that we don't maybe necessarily have to wear all this arc flash hoods and all these type of things in some situations, which from an electrical workers perspective, that's really, they're like, oh, finally, I can maybe get away from having to wear all of this really, really burdensome equipment. And we have some validation that is a good decision or a reasonable decision to make when doing that. In the case of my shirt is actually would fit the old category 2 method because it's 8.7 calorie per square centimeter rated shirt. And what that means is if I were in that type of situation, I would have a 50-50 chance of getting a 2nd degree burn. So even though I have PPE on, it still doesn't protect us from 100% certainty that we're not going to have a burn or a thermal burn on ourselves when we get involved in something. There is a section in NFPA 70E that talks about the hierarchy of risk controls. And we have this whole process of elimination all the way through PPE, administrative controls, these type of things. I'll show you what some of these kind of look like. The biggest one, the most important one, the driving factor for anything related to electrical safety is this idea of elimination. So the only way we can eliminate the hazard is to isolate the power, shut it off, get it locked out, and then use our meter to verify that the power is absent. And a lot of times I see that people get it in their head that they want to just shut the power off and maybe hit a start button to see if the motor starts. But we really need to use a meter for these type of conversations to prove that the power is actually gone. So I've got some examples of that I'm going to show you. What's interesting is when I do training, if you think about yourself, if you're an electrical worker and you're using your meter to verify the power is out on a simple disconnect, for instance, there is a process to use, and you actually, to do the process right on a 3-phase piece of equipment, we're going to use our meter 8 times to measure voltage. And it seems like, well, how can you do that, Phil? That's just a 3-phase piece of equipment. But really, we have all these different phases. We need to do phase to ground measurements, phase to phase measurements. Then we have to do a pre-measure with our meter to make sure our meter is working, and a post-measure with our meter to make sure our meter didn't blow up in the process. Very, very scripted. But once we get used to doing it, we got to develop habits around it. But once we get used to doing it, then we're like, okay, then we can start moving on from there. But a lot of times it takes a little bit of work to get there. So let's talk about what some of those hierarchy of controls, what are some of these controls we could put into place that might make this electrical safety task easier to adopt? So this first one is a thermal scanning window. And what this is, a lot of times with large switch gear, we have really high incident energy on it, and we have challenges. We get reluctant to take the cover off the panel, because if you remember, removing the cover is one of the most dangerous things we can do as an electrical worker. So if I can put some things into place that eliminate me from having to kind of make it so I don't have to pull the cover off, that's really a good thing. So this actual device is it's a special crystal type of lens on this piece of equipment. Maybe that piece of equipment, I don't know, maybe it's $400 or $500. I'm not 100% sure. But this is designed to cut into the front face of large switch gear, so we can use a thermal camera to photo or take a thermal image through the lens itself. And we're starting to see more and more of these installed on switch gear, for instance. So if you think of your own situation, if you have an electrical gear room and you have a large piece of switch gear, this could maybe fit in front of the lugs, perhaps, of your switch gear. So that way, when we take a picture through there, we can take a picture of that probable failure point where the 3 phases come in from your transformer. They can come from all over the place, but this would be the engineering control that would help things. In the case of thermal scanning, you can't do thermal scanning without pulling the cover off unless you have this type of thing. So people who do thermal scanning really, really smile when they see one of these things out and about. This here is a reduced energy let through switch. So what this is a way to interface. This is going to sound a little bit abstract, so I'm sorry for that, but this, when activated, takes the main circuit breaker, and when installed correctly, will change the sensitivity levels within that breaker. So that way, if there's a arc flash or a short circuit downstream of this breaker, when this little switch is turned on, it will make the breaker more sensitive and interrupt that current flow quicker. In the case of arc flash and electrical safety, milliseconds count. So if we can interrupt that current flow a lot faster, that means less energy is getting through the wire to wherever the person is working. And these are actually required by the National Electric Code on some instances. The National Electric Code is changing that area. They're making them even more required than they were in the past. I'm not an electrician, so the exact details of how the requirements per se might work, but we're seeing these more and more often in the field. And if you have these in your plant and you ask your maintenance workers if they're aware of them, what I found is a lot of times they're installed and people don't even realize that they're there, nor do they even know how to use them once they find them. And they can have a really instrumental effect on arc flash energy. They're a great thing. Drawings, understanding these things. I think that electrical workers, a lot of times they'll go places, even if they've had a arc flash risk assessment done and they have all these drawings and things, they don't really understand how to use the drawings to their benefit. So that is an information type of thing. An elemental way for people to understand where power is coming from can be had by having them understand how to read drawings. And my own personal sense is, if we can teach people how to do some of these things, the employee really, really appreciates our help there. And I think it makes them more engaged with the whole company when they start to feel that their own skills are being built by you too. And these are very important. They're required by NFPA 70E to be kept up to date as well. So it's kind of an interesting thing. Data, we can have all kinds of data from all types of places. And let us see, I think I might get myself off track. So yeah, so when we get done with our risk assessment, we want to determine how hazardous the area is and the probability of something happening, and then find some way to build a risk matrix off of that data. And that's an area that's a growing area in electrical safety that we haven't seen a lot of places do this. But if you think about it, in the world of general safety, if you're a normal safety professional, not specifically in electrical, you're used to working with a risk matrix for certain areas. And we're starting to see more development in a risk matrix area to really get a better idea how this data will affect our allowances for electrical workers to be doing some things in some areas. So yeah. I've got a heart for this conversation about qualified workers versus non-qualified. And it's an interesting conversation, because even though myself, I've done a lot of wiring work, I've done a lot of troubleshooting work, I've got all kinds of electrical safety PPE, I've been in all kinds of different places and all kinds of different industries. It's what I do. I'm still not qualified to do any of that electrical work anywhere. And even if somebody told me that, Phil, we'd be fine with you doing that because you appear to be a good instructor, you understand the hazards and stuff, I really recognize my own lane for where I'm working. And we encourage people to make sure that they stay in their own lane. Earlier this month, I was training a group of electricians. There were 14 electricians. One of them was not a master or journeyman. So I had 13 masters and journeymen in the room, but each one of those people were qualified to do what they were qualified to do. And it sounds kind of like, oh, what do you mean, Phil? Well, we have to recognize where our own stop work kind of limit is. So in my case, I recognize very clearly if somebody's doing electrical work at a customer site, my job is usually just to observe them. And occasionally I might photo document something if I'm allowed to do it, and then maybe give some advice and guidance on how that particular task or activity might be done safer. And it's not necessarily my role to teach them how to do the task, but if they are going to do the task, my role is to really help them do it safer. So even in my own case, I work in that qualified space just to that level. So, but if the qualified persons are required by NFPA 70E to have training every 3 years at a minimum, unqualified persons as well are required to have training every 3 years as well too. So you may want to just from your own perspective, may want to think about that for your own sake to make sure that you've got yourself, your team is covered in that area. So. Yeah, training requirements in the case of that qualified person, we want to make sure they know how to do good job planning. We want to make sure that they're keeping up their own education. We want to make sure that they're keeping up with their own rescue training. So if something bad happens, what should they do? There's so many different facets to it. And it can be sometimes feel like a lot, but it is. There's a lot happening with power systems. There's a lot of moving parts. And again, when something happens, a lot of times the results can be so horrific that we wish we would have maybe taken a different approach to things. So we're going to switch to have Ray talk about evaluations and NFPA 70 and how they relate together.
Awesome. Thank you, Phil. And, Phil said it correctly the last couple of slides, right? We got to make sure that our qualified and competent persons are getting regular training. It's not a one and done training solution. You got to make sure that we're doing those refresher training, especially if there's going to be gaps, right? But when we look to the annual evaluation for NFPA 70E, we're making sure that those trainings are done. If refresher trainings should be occurring, those are done as well. We're looking at things like best practices, right? So if you've unfortunately had safety events or electrical safety events, you want to make sure that those corrective actions are good, those best practices, your SOPs are in place. So things like your safety policies and procedures, all the way through if you've completed an arc flash risk assessment, right? All of those things are handled in place, and that should be done at least once a year at a minimum, right? Getting more into training here on this next slide. You heard Phil mentioned every 3 years is the requirement under NFPA 70E, and or it could be more frequent, right? You certainly can do it as needed under your policy, but if during the annual evaluation process that I just mentioned, if there's a failure that's recognized or some sort of a gap, you want to make sure that we repeat training. If you have management of change process, right, where you're identifying maybe new work tasks, maybe you have new equipment, maybe there's a new procedure, we'll want to make sure that we do additional training. I work quite a bit in the powerhouse industry, and I could remember contractors or being a contractor where you would scoot into the facility and they would have some sort of training that was required, and you'd sit through that. Workers would walk away that didn't functionally have a whole lot of experience with electrical safety, thinking that sitting through one of those classes was good enough. And as Phil said, you gotta be able to police yourself and know your own limits. A lot of these trainings that contractors sit through are just a general awareness, just to turn on some light bulbs and raise awareness that there are these types of electrical hazards. These types of trainings are going to be more formal trainings for your competent and your qualified persons. where not only are you doing knowledge checks, but you're having to demonstrate your proficiency and skill. If there's certain tasks that are done less than once annually, another good reason for training. And if there's unusual situations, or circumstances, right, the uniques, that might be an advocate for additional training. And then obviously when there's job changes. So if we're functionally moving through different work activities that present electrical hazards, we'll want to be mindful of that as well and make sure that we do the adequate training as well. A little bit more training before I hand it back to Phil here on the next slide. Document, document, document. You want to document your training. So you should have some system in place for making sure that you're capturing, the syllabus, the objectives, but then also you're certifying the training was completed. Many times this is in the form of a worker signing a sign-in sheet. But again, I've seen a lot of gaps over the years, especially where I've evaluated contractors. And yep, we did the training, but they couldn't necessarily produce the training syllabus or objectives. And so make sure we have those. You want to retain the documentation at least for the length of the worker's employment. And again, this could change, if you're in an established facility where you have long-term workers versus if you're in the construction industry where you got more transient workers. Your archiving, record keeping methodology might change. But you, again, want to make sure that you got all those tag-alongs. Make sure that the worker's name is legible. Make sure that the training date is legible. Take time and go through that. And I'll tell you that I've been involved in many OSHA investigations where whether or not we got cited hinged on whether we could identify somebody having received training. And then when we looked at the syllabus, we couldn't interpret the scribble. And if we couldn't interpret the scribble, nor could OSHA, and then it prompted cause for a citation. So take the time, go through your documentation, make sure it's good to go right after the training. So that way, if it needs to be revisited later on, it's legible and good to go. Right. I think, Phil, in the next segment here, you're getting into emergency response training.
Right on. I spend a lot of time grading papers, Ray. Grading papers. It's awesome. So yeah, we got to make sure the documentation is there. Make sure somebody actually learned something. Yeah, it's interesting. So on our next slide, we talk about, Ray mentioned emergency response training. So this is a specific requirement as an annual refresher from NFPA 70E. So annual refresher on contact release training. And some years ago, I was reading NFPA 70E early on in my electrical safety career. And I saw this in here and I knew it was in there and I was not comfortable with creating material for that training. I couldn't find any. I really struggled trying to find a good electrical safety rescue training course or anything. And I really was challenged by that. And so I took it upon myself to create it myself. I'm an emergency medical responder in Minnesota. So I keep up with continuing education for emergency rescue and response. When I'm doing field survey work, I carry the tools for contact release methods with me. So I have one of those rolling toolboxes I do site survey work with. I carry it with me. In there, I have an AED. I have a nylon strap that I might be able to use to rescue somebody. I've got a pair of scissors so I can cut somebody's shirt open if I need to put my AED on them. I've got voltage rated gloves with me. I wear electrical hazard rated boots. So I've got a whole, for lack of a better term, a MacGyver kit that I can use to, if I come across somebody who's getting electrocuted, to help get them out of that situation. And so that is an annual refresher training requirement. And I find a lot of times when I go places, like people say, I've never even had this training once before, if it's my first visit there. So I always do it whenever I do any kind of training with anybody. But people sometimes get a little bit uncomfortable when I tell them that, hey, if somebody comes up to me, if Ray came up to me and said, hey, I just got shocked, Phil, my priority for Ray is to get him comfortable, get him on the ground, get my AED on him, cut his shirt off him, get help coming, and keep him alive until help comes. And what Ray's biggest problem in that situation is cardiac arrest. So I need to be set up with my, if I have my AED with me, I'm going to get my AED on Ray, and I'm going to get ready to break his ribs. Because when we do chest compressions, we're breaking ribs. And so that's where my strategy is, because I need to be ready to do CPR if Ray checks out on me, and that's just the way it is. And a lot of times people get really uncomfortable with that conversation, but that's really that's the response we want to have. We want to treat those shock incidents in a real aggressive way to help prevent any kind of situation from manifesting itself any worse than it already is. So we have a survey question. So we're going to pop that up there. Alan and Barry are going to take care of that. And then if you want to fill that out, I'll give you a second or two, and then we'll keep moving.
Yeah, just to throw a little tidbit out here, Phil, if anybody in the audience would like more information on the items that we've been talking about or the electrical safety training, let us know. That poll that's up there, you're going to select your interests. And as a thank you, we're going to go ahead and send you our popular electrical safety training requirements guide. So all the great things that Phil and I are talking about here today with you, lots of it will be included inside of that guide. So make sure you let us know what you're thinking and answer that poll for us.
Very good. Thanks, Ray. So we're going to keep moving. We're running against the clock, right? So we're going to take a look at some of these other things. When the world of protective equipment from electrocution type injuries, we need to add distance and add material between us and those electrocution hazards. The way we can do that, of course, with voltage rated gloves, or we have myself, I wear electrical hazard rated boots. So they actually have insulation in the soles of the boot, so that if I were to if it were a pathway to ground through the ground, I would have some protection from that. Some of the other things that we see are insulating mats, and sometimes you're most familiar with them is if you're seeing a line crew working somewhere, you look up high up on those high wire lines, they'll have rubber blankets and types of things protecting the area from incidental contact, but we can use those in industrial facilities as well. And a lot of times I find people that could really benefit from having those type of things really put into place in their situation. When I do training, I ask a lot of questions about whether or not somebody should have those voltage rated sleeves or those real long sleeves. And that's oftentimes a interesting conversation, because sometimes when I see electrical workers working, they're getting their body within that 12-inch approach boundary to 480. It might be their elbow where they have no shock protection gear on, and it can be an issue. So we wanted to take some special care for that. Let's make sure we're staying on track here. Yeah, so we got to protect from our shock hazards, and of course we want to protect from arc flash hazards as well, right? That's just kind of the rule of things. With arc flash hazards, a lot of times we'll have that face protection, head protection, a balaclava, something on our upper body, our lower body. And in most instances, the voltage rated gloves with protectors on them are what we're going to use for protecting ourselves from arc flash hazards at our hands. If you are in a plant that has arc flash labels on it, you'll see that 18-inch working distance. So the idea is we calculate 1.5 feet away from where that point of exposure would be, because that's where our face is. And the number that's on the arc flash label then gives us an indicator of what kind of gear we need to wear to prevent ourselves from some sort of thermal burn. It doesn't prevent the thermal burn, but the idea is the math is built on this premise that we're trying to prevent, we want a 50-50 chance of people not getting a second-degree burn or worse. That's the idea. So if those odds are not good enough for you, then we need to maybe take a different approach to things. But there was a survey done years ago, and it was determined by the general public has determined that electrical workers suffering a second-degree burn is an acceptable level of risk. And a lot of times when I make people aware of that, they're like, that's not acceptable at all. I don't want that. This isn't good at all. And it's just one of those things, right? It kind of comes along for the ride. And if we don't pay attention to some of those small details like that, we can end up getting down the pathway on something and not really having a good handle on how this whole system of PPE selection and things were put together for us. So Ray had talked about that earlier, but it can be a pretty big topic when you dig into it. So now we got another opportunity for Ray. Ray, do you want to talk about this chat setup?
Yeah, let us know what you're thinking. This is going to tiptoe into our next section, lockout, tag out. Do you do lockout? Do you do tag out? Do you do both? Let us know what you're thinking. Go ahead and put your thoughts into the chat. Looks like a lot of folks are doing both, maybe just lockout. Very few are doing just the tag out. But it looks like a lot of our audience is doing both. Well, good. Let's jump into the next section here, which is that lockout tag out section. Couple of things I like to point out is that, you know, there's a different place that we go to when we're talking about electrical lockout tag out. The 1910-147 which most folks that are just doing servicing and maintenance of machines is going to discuss, obviously, the unexpected energization or startup of machines or equipment. And so if you have those situations where you're trying to control hazardous energy, and you're looking for the standard under the electrical lockout tagout 1910.333B, like boy. And some of the requirements, you want to place a lock and or a tag on each disconnecting means, use to de-energize circuits and equipment. You want to attach the lock to prevent persons from operating the disconnecting means. This is very important, right? You don't want folks, bystanders or other folks coming in and disturbing the process and energizing the system. You want to ensure that the tag, right, contains the proper statement prohibiting any unauthorized operation or removal of the tag, right? And that needs to be on the tag. If for whatever reason, and this happens a lot in facilities, older plants, if the lock for whatever reason can't be applied, and if you can demonstrate that the tagging procedure will provide a level of safety that's equivalent, that to be obtained by using a lock, then you can go ahead and use a tag. I've seen a lot of times in facilities that I've worked for, modifications of systems so that way they could accommodate locks, but with aging equipment and aging facilities, you may run into that situation. Now, remember that a lock may only be placed without a tag in certain circumstances, and I'll throw a couple of these out at you. Only, one circuit or piece of equipment is de-energized, right? The lockout period doesn't extend beyond the work shift. And then the last nugget would be along the lines of employees exposed to the hazards associated with re-energization. The circuit or the equipment are familiar with the procedure, and that's going to go back to our training processes. Alerting is going to be pretty big. You want to make sure that you got those safety signs and symbols in place, accident prevention tags, barricades, right? Soft barricades or hard barricades. Preference is going to be the hard barricades. And you want to have an attendant, right? Somebody that can go ahead and dress up our barricades and or be a point of contact. And so you want to make sure that you got your alerting techniques in place. On this next slide here, just to kind of highlight, we want to make sure that our workers have that experience and that we got those proper training protocols in place. You want to make sure that you got your electrical program, your lockout tagout procedures. It could be different contractor versus owner of the facility. And so we want to make sure that we spell all of those out. Employer responsibilities, right? Providing the lockout tagout equipment, doing proper training, doing the audits that Phil and I have talked about, and then establishing those auditing procedures and guidelines, okay? On the next slide here, just with lockout devices, right? I mean, the locks could either be keyed or combination locks under NFPA 70E. You want to make sure that you got the locks that are properly identified, right? Whoever is going to be applying them. You could just be using a lock, right? You want to make sure that you got a proper attachment points to your equipment, so that way you can attach that lock. As I mentioned, with aging equipment and aging facilities, you might run into some challenges or what have you, and so there's always going to be some nuances. Tags with locks are going to be important, and as I mentioned, that making sure that we identify who the applier is. Make sure that they're suitable for the locations that we're working in. And then making sure that if we're using a key or a combination, whatever it might be, that they're under the control of the applier, right? On the tag outside of the fence, right, we want to make sure that tags are in place properly and that they're conspicuous, that we can see them, that they're identifiable, they're suitable for the environment, indoor versus outdoor, weather elements, that they can't just be pulled off with ease, right? There's a 50 pounds of force stance there with the grommets, and then making sure that they have the proper statements. And all of this stuff is going to be spelled out in your lockout tagout program. And then just this next slide here, establishing the right procedures, right? You're going to have to look at things like your electrical line drawings, your employee exposures, right? Doing those hazard assessments. PPE, as Phil and I mentioned earlier, And then you want to make sure that you have an established, qualified, and competent persons in charge of your program, so that way we can ask the right questions. All right, Phil, back to you.
All right, so why is this so important? Well, there's a lot of times when we do electrical hazard and type of risk assessments, some of the, here's a bunch of pictures of things that I found out in the field or that I find as a kind of a normal course of action. This one here is an incorrectly rated multimeter. So this little cat number on a voltmeter, it means a lot. And I think that a lot of people don't understand how to apply that. And we can't figure out what this means until we understand what level of available fault current is in the power system. This one here, you can see that this air conditioner here overflowed, ran water through an electrical panel. Kind of just, again, I find these things all the time, but when we're out and about in our plants, in our workplaces, we should be looking for these things. They should get fixed. They shouldn't be left in the condition that they're in. Here's another one. This is, again, electrical box, some sort of control panel of some sort got hit by a forklift or something. Can we count on that being in working condition underneath that? No, we can't. We got to fix that stuff. This one here, you can see we work in some very challenging environments. This picture came out of a lumber mill, actually. And you can see the sawdust and cobwebs and everything else inside of that switchgear. Is it going to short circuit if some water gets caught up inside of that little cobweb in between those two phase connectors? That could be a real ugly situation right there. This one here, one of my all-time just least favorites. If you have this going on in your plant, you got some issues, right? These are just things I find though. People taped over. This is probably a $16,400 fine, give or take, from OSHA, just because it's just a single instance type of thing. This one here is a motor control center. This is a bucket on a motor control center. Somebody was storing electrical gear and cables and stuff in it. And if you look on the back side of this, there's, I don't believe there's any shutters on this one. So there's a good chance there'd be an energized 480 on the back side of that. And they were just going in and out of that with abandon. So yeah. Wrapping it up, we know that this electrical situation, very, very dangerous. And we're here to help you. And we got ways to do that. We can do an arc flash risk assessment, shock hazard risk assessment. If you're manufacturing special equipment, I work with some people are making battery powered equipment, that type of stuff, where we're really getting a better look at the hazards that are involved in what they are doing there too as well. There were a couple of questions in here, Ray. I'm just going to take a shot at answering a couple of them. Hearing protection, there's somebody asked a question about arc flash, whether hearing protection is required. A hearing protection is required above certain levels of incident energy. So that's an NFPA 70E direct question there. Typically 1.2 calories or more is where we need to wear hearing protection for arc flash. Most places I go to is required to have hearing protection regardless anyway. Somebody asks, does provide first aid CPR training translate into everyone working with electricity shall have that? The standard tells us for those who are required to have it, they shall keep it up to date. So that's a different direction other than NFPA 70E. Another person, do you think everyone should be CPR certified? In my case, I would like people to know how to use CPR, so that way if I got electrocuted or if I got shocked, that they can help, because our CPR is really going to be the first thing that I'm going to need help with if I've gotten shocked or gotten electrocuted. My heart situation is really what I think would be the best situation there. Somebody else asked, I've noticed that a lot of electricians say it's okay to remove covers off of panels without de-energizing. They especially say they can remove the front cover. What would you advise? I'd advise they have to do a hazard risk assessment to determine how hazardous that activity is. And then also wear the correct PPE to deal with that hazard if they haven't mitigated it in some other way. So to just go and pull the cover off of a breaker panel and unscrew it and take the cover off, the first thing to me is if they don't have voltage rated gloves on, more than likely they're doing it wrong. So I'd be really careful on that. There was another question about NFPA 70B. NFPA 70B, kind of the jury is still out on that one for those of you who don't know. NFPA 70E is a maintenance standard. It used to be a recommendation. It's a standard now. It became a standard at the beginning of last year, and it's a specification on how to do maintenance on power systems. And I'm not an NFPA 70B expert. I don't believe there's a training requirement in there, but I could be wrong. So with that, I'll turn it back to Alan and Barry for a wrap up.
Okay, well, yeah, thank you so much. Unfortunately, we have run out of time today. I'd like to thank our awesome presenters, Phil Hadia, Ray Chishti, the entire team from our sponsor, JJ Keller, and of course, all you've joined us today. Take care and have a safe day.